This video is on the Stoichiometry Lab, which is located in week 10. So these are the pre-lab questions. The first one is to balance the equation, and if you'll notice in your lab it already has that balanced for you, but you know how to balance an equation. Okay, then it asks you to find the molar mass, and in all three of these you're finding the molar mass. So to find the molar mass, you're going to list what elements you have and how many that you have of each one, and then you're going to multiply by the atomic weight on the periodic table. And then you're going to add those up. So for this one I got 110, and it looks like, depending on how many, you're going to round by your decimal places, so I'm going to round it to 2. It depends on the periodic table that you're using, how many decimal places, but round it to the least amount of decimal places. And then you're going to label it grams per mole. Okay, then you're going to do the same process for the calcium carbonate and the same process for the sodium carbonate. And remember, like, this 3 just goes to the O, not to the C. The only way it would go to the C is if you had a parenthesis, but you don't. Okay, so then you should have your data table filled in, and your numbers should be close. Like this one, they told you to weigh out 2 grams, so you should be close to 2 grams. This one, you were supposed to weigh out 2.5, so it should be close to that. Alright, then you're going to put in your observations of what happened in the reactions, and you're going to put a picture of what your dried filter paper looked like here. So now we're going to go on to the calculations. So it says using the mass of calcium chloride, so my mass of calcium chloride is 2 grams, and the molar mass, and the molar mass is the one that we just found over here, which is the 110. I'm supposed to calculate the number of moles. So I'm going to take my 2.0 grams of calcium chloride. I'm going to go to moles. I'm going to divide by the molar mass. This was 110.99 grams in 1 mole. So those grams would cancel. And since I had 2 significant figures here, I'm going to round my answer to 2. And now I've changed this to moles, so this is going to be moles of calcium chloride. Okay, then we're asked to do a mole ratio. So I'm going to have to find the coefficients for those 2 things in my balanced equation. So the calcium chloride and the calcium carbonate. And you'll have to make sure that when this is balanced, you're going to look at the number that you have here and the number that you have here. Now, I know that when you balance this, there's going to be a 1 here and a 1 here. So I have 0.018 moles calcium chloride, and then my mole ratio is going to be the moles calcium chloride here, because they have to cancel, and up here is moles of calcium carbonate. And these are the coefficients from the equations. And I just told you that this was a 1 and this was a 1. Those cancel, so that's my label. Okay, then the next step is I have to take my moles of calcium carbonate and I have to convert that to grams of calcium carbonate. So to do that, I'm going to need the molar mass. So 1 mole of calcium carbonate, and the molar mass you're going to find in number 3. So your number 3 answer there in grams is going to go there. And then you'll label this grams of calcium carbonate. Okay, then 4 is going to have you go through and do this same process, except you're going to be using sodium carbonate, and so you're going to be using the grams of the sodium carbonate and the molar mass of sodium carbonate that you found from your data table. And then you're going to go on to 5. And 5 is going to ask you to do a mole to mole ratio. This time you'll use the coefficients for this one and this one. And you're going to set it up like this, except this is going to be sodium carbonate, this is going to be sodium carbonate, and these are going to be the coefficients that you're going to find in your balanced equation. And then 6, you're going to go from grams of sodium carbonate, or from your grams of your moles of calcium carbonate to your grams. And you're going to use it, set it up just like this one. So you're going to have here your answer from number 5, and then you're going to be using your answer from number 3 on the front, the molar mass, and convert that to grams. Okay, then number 7 says you're going to look at your answers to questions 3 and 6. Now both of those are telling you grams of calcium carbonate. One of them, the one from number 3, is the one that you got of from calcium chloride, and the one from number 6 is the one that you got from the sodium carbonate. And it says determine which of those is the limiting reactant, meaning is it this one or this one? And you can tell that because it's going to be whichever one is smallest. So if your answer to number 3 is the smallest, that means calcium chloride is the limiting reactant. But if your answer to number 6 is the smallest, that means sodium carbonate is going to be the limiting reactant. And then the theoretical yield is going to be the answer to questions 3 or 6, whichever is the smallest. Okay, then the experimental yield is going to be from your data table. So where it says calcium carbonate experimental yield, you're just going to write that same number here. And then number 9, you're going to use this equation to find your percent yield. So the experimental yield that you just wrote in number 8, and then the theoretical yield is going to be what you wrote down for number 7, whichever one was the smallest of 3 or 6. And you're going to divide those and take it times 100, and that should be your percent yield. And for almost all of these, since you were starting with 2 significant figures in either case, then that means 2 significant figures is going to be your limiting reactant. Or, sorry, your limiting number of significant figures. So that means in all of your answers for all of these, those should be rounded to 2 significant figures. Okay, and then there's some post-lab questions. So hopefully that helps with your lab.